In today's tutorial, I am going to show you how you can count the number of variants in a VCF file based on chromosomes. And so what we are going to do is that we are going to count the number of variants that have been found or identified on each chromosome in the VCF file. And the tool we are going to use is bcftools. In order for you to follow this tutorial, you need to make sure you have a Unix-like operating system, i.e. Linux or macOS. Any of these operating systems will be fine for this tutorial. In addition, you should have bcftools installed on that PC. And I have a separate tutorial that shows you how to install bcftools on your PC. So just watch that to set up your PC. Without further ado, let's start the exercise. We will begin by first downloading an example data. Okay, so we are going to use a VCF file which is available on my GitHub repo. And this is the page. I'll leave the link in the description box for you to also visit this repo and then download it. For this exercise, we are going to use this file, all.snipsindex.vcf.gz. This file is what we are going to use. To download it, you first have to click on it. You can also double click. And then you'll be sent to another page. On this page, move to the right side. Just follow my cursor. Move to the right side and you'll see a download button here. So there's a button labeled download. That is what we are going to use. I'll show you two approaches to use to download this file. The first approach is used if you want to download using the browser. What you do is to click on it and then you'll be asked to save. So I'll save it on my PC. Make sure you save it in a location where you have access to the file. Okay, so there's one way to download the file. The other approach is used if you are working on a remote server where you have access to only the terminal or the command line. For that, you need to have the download link. Okay, so that is what you need. So to get the download link, still bring your cursor over to the button. And then what you do is to just right click it. Okay, so once you right click it, you go to this copy link here and then just click on it. Okay. So I am using a Firefox browser, so this is how I do it. But using the other browsers to be able to get the download link. So once you have this download link, you move to the terminal and continue from there. So on the terminal, the first thing I will do is to create a working directory. So I will say make the VCFs. I will then cd to it. The reason why I do this is to separate files that I'll be generating for this exercise from other files on my PC. Okay, so doing this helps you to organize your files and prevent accidental removal of files and modification of files. So that is why I create directories for every project that I do. So now it's time to download the data. So I'll use wget for it. So I'll say wget and I'll supply it with the download link of the file, the VCF file. And then I'll run it. Please take note that aside wget, there are other tools that can help you to download files from the internet. Okay, so just use an appropriate tool to get your data downloaded. So let's run this command. So now the data has been downloaded. Let's first clear the screen and continue. Let's do an ls to check the file. So there we have it. The next thing to do is to perform indexing. Indexing helps programs to do a faster lookup of information in the VCF file. So we say bcftools index and we specify the VCF file. Let's run this command. Now indexing has been done. Do an ls and you'll find this file created for you. That's the index file. Now we can continue. To count the variants per chromosome, you need to even get the chromosomes. You need to get the list. Okay, we need to find out which chromosomes have records there. Okay, so to do that, we need to first list the chromosomes. We will display them and then continue. So to get the chromosomes, we say bcftools query-f. We bring a quote, have this percentage symbol, and then chrom. And then we add /n. And then we specify the VCF file. So with this command, the -f here is formatting, is format. Okay, so we have format and then we have this. This particular phrase here indicates the column, okay, the column from which we want to extract the information, the column from which bcftools should get the information. Okay, that is why we have this here. So what this phrase means that we want bcftools to return information and that are present under this column called chrom. Okay, there's a column chrom. Okay, so that's for chromosome. So that is why we have this command there. So let's run it. Now we have it done for us. Notice there are duplicates. Okay, we have SSSS, we have YYYY, but we just want the lists. Okay, the reason why we have this happen is that bcftools will return information for each variant. So that is why we have this duplicate. So each of these here represents a variant. Okay, so we can even use this list here to count the total variants in the file, but that's for another video. So let's proceed with this particular one. So what we want to do is to just get the list. So we would like to remove the duplicates so that we have just one X, just one Y, one for each entry. Okay, so let's clear the screen and then modify the command. So with the command here, what we will do is to add this. We will pipe and then add this here, unique. So the unique command here in Linux removes duplicates. So that is why we are going to use this. So this will remove duplicates for us. So let's run this command. Great. Notice that we have what? One for each chromosome. Okay, so that's what we want to achieve, and we've done that using the unique command. So this is how we use Linux to get some of these things done for us, in addition to the tools we are using. So that's how it is. So from here, we can even count the chromosomes. Let's clear the screen. Let's count. With the same command here, we can do another pipe and say wc-l. And that will give us the count. So we have 24 entries here, which is good because now we have the list. Okay, but what we did here was to display it. But then it will be good to save this list to a file. So we will save this to an output file, which is a text file, by the way. Let's clear the screen and continue. So to save this list to a text file, the same command here, we will add this symbol here and then just specify a text file. So let's say chromosomes.txt. So once we have this, we can run this command. So now when you do an ls, you will find this file here, which contains the chromosomes. Let's do a head-n5 just to get the first 5 in the file. So we have them here. We can also display everything by using the cat command, and it will display everything for us. So now we are ready to go. We now have the list, so it's time to do the counts. So let's clear the screen first. We are now ready to do the counts. So for the counts, we are going to count variants for all the chromosomes. Okay, so we are not going to look at specific regions within a chromosome, but the entire chromosome. Okay, so that's what we are going to do. So I'll make a future video where I focus more on the region-based counts, okay, for maybe specific chromosomes. But this tutorial, we are looking at the entire chromosomes, all variants for a particular chromosome. Now let's proceed. Let's first display the first two entries for the text file, the chromosomes text file. Let's look at this. Okay, so let's say we want to count the number of variants for chromosome 10. Here's how we do it. We first do a subset and then we count the variants. So we say bcftools view and we add -r and we specify 10. Okay, R is region and then 10 is for chromosome 10. Okay, but because we are specifying only 10, all variants for that particular chromosome, okay, all regions for that particular chromosome, okay, will have the variants they're being counted. That is what we are doing. So we specify the VCF file here. Okay, so now what we've done is subsets. Okay, so we've subsetted the VCF file to get variant for this region. Okay, so now we can count. So to count, we use a grep. I have done a separate video on how to count variants, so you can just watch that to understand some of the things I'll do here. I've made that video and I gave a full explanation of some of the things there, so just go there to check that video out. The link is in the description box, you can just check it out. Now let's continue. After doing the subsets, we use a pipe and now we can count the variants. So we say grep -v-c and then we have our pattern here. That's how we do it. Okay, so the grep will look for patterns. -v here indicates we want inverted match. Okay, so that means that whatever pattern we've specified, Linus should return lines that do not contain those patterns. So that's why you have the v here. Okay, so it's like saying that's not present. Let's put it that way. -c here is for counting the hits, and then here it's for what? The pattern we want. So we want lines that do not begin with hash. Okay, that's for the variant. So that's what we do here. So now let's run this. So now when we run it, we have this here. Okay, that's what we have here. Okay, so that's what we do. We can also use this approach here. Instead of R, we can say T. And then that will also give us the same answer. Okay, so sometimes you may want to switch between the T and then the R. Okay, and there are situations where you have to use both to get the answer that you want. But we'll just do with R for this tutorial. If you want more information, just go to the bcftools manual page to get more information about some of these options. We are just scratching the surface here. So we have it here. So let's say we want chromosome 11. We want variants for chromosome 11. The same command here with the R here, but this time we add this. We change the 10 to 11. So that will give us the total variants. We can also look at the total variant for what? 2 chromosomes. Let's say we want the total variant for chromosome 10 and 11, all of them. We can just add them here. So we have 10 and then we add the comma and then, so we can just separate them with commas. bcftools will know what to do. So the chromosomes of interest, if you have the list, you just add them and then you separate them with comma. So this will give us everything here. Okay, so that's what we do here. If you count, you will know that it's correct. You can add more than 2. I mean, these are things that you have to just explore. You can add, let's say, chromosome 12. So that's what we have. So this will give us the variants, okay, the total variants for this combined, everything combined. That is what this will give you. Okay, so if you want individual ones, you just specify them individually. But we'll look at how to automate this process. Now, you can have situations where you want to exclude certain chromosomes from the list of chromosomes that you want to count their variants. Okay, so let's just say you want to count the variants for all the chromosomes except 10. How do you do this? You also do that here. So let's write a command that will count the total variants minus that of chromosome 10. So to do that, we say bcftools view, and we say -t. We use this one, and then we give our caret symbol, and then we indicate 10 like this, and then we specify the VCF file, and then we pipe and get our grep command here. And then we can run this command to count the total variant minus that of 10. Okay, so let's run this. So this will return the total variance minus this one. So the carets here indicate that we want to exclude this chromosome. So that is what we have here. You can still do it. Let's say we want to exclude 2. You can just bring the comma here and add the other one as well. And that will also give you the counts. Okay, so that's how we do it. But we are just scratching the surface. So sometimes doing the bcftools view with -r or -t might lead to getting variants that overlap. So you need to be able to read the documentations and then just do some manual checks as well to confirm that you've gotten the expected results. So take note of that. Now let's proceed. So let's clear the screen and then continue from here. So far we have been able to do the counting for some of the chromosomes. Let's display the list again. Okay, we did for some of them here. Okay, but sometimes we want the counting to be done for all the chromosomes. Okay, and so if you have a situation like this, let's clear the screen first. Then you might be tempted to use this command here and then just be changing this portion here just to accommodate the chromosomes. But if you do it this way, that means you are going to write this command multiple times. Okay, in our case about 24 times. But there is a better way to do it. Okay, so we are going to look at how we can automate this process and count these variants for each of the chromosomes we have. So let's clear the screen and then continue. Let's do an ls first just to check things up. Now we are going to create a script, a batch script to help us do this. And so what we will do is to first create that file. So we use touch to do it. So we say touch and then we just give it a name. Let's say variant counts. So we have created this file. Do an ls and you will find it here. This is an empty file. So we will now have to edit and then place in our commands. That will be the next activity we'll do. So to edit, we can use any text editor. Okay, this is a text file. So any text editor should be fine. Nano, VI, Vim, etc. Just use any appropriate one. I will use Nano to do this. So I will say Nano and then I will specify the file here. And then I will open and start editing. The first line will contain my shebang line. This line tells the Linux interpreter to use bash to run the scripts. Okay, so that is why I have this here. The next line here will be an array that contains the lists. That contains the list of chromosomes I am interested in. So I'll say chrom list equals cat chromosomes.txt. The cat here will display the contents of this text file. Okay, but then this here, okay, tells bash to put everything, the output here, into an array. And then the equal sign here will let bash assign this entire operation, the value of this entire operation, the outputs to this variable here. That is what it means. Let's move to the next line. So the next line here, we will use loops to iterate through the list and get each member and perform an operation on it. So we use the for loop. So I'll say for chrome in this. Okay, so here this means that we want batch to make available all the members in this array. Okay, that is what we have here. So once we have all the members available, then we iterate and get them. Each member, okay, each item in this array will be called, and then an operation or some operations will be performed on them. Okay, so will be performed on each of these elements. So the next line here we have do. So do here is where we put the operations. Okay, so do here says that once we iterate and we get each member, perform these operations on them, and those operations will come after the do. So we say we are going to do the counting. So the counting is the operation. So we say count, we assign to a variable. So we say count equals bcftools u-r $chrome. $chrome here indicates the value of chrome. The chrome here is a placeholder for each of the elements because we are iterating. Okay, it's like picking maybe pebbles, groups of pebbles, picking them one by one and putting them in a basket. So we pick each of them and then the operation is to put in a basket. So this time around, once we pick, okay, we perform the operation here. Okay, so at each point in time, this here is a placeholder indicating that particular chromosome. Okay, so that is what we have here. So we now specify the VCF file here, and then we pipe and add our grep command to do the counting for us, like this, and then we close it. So the dollar here also tells batch that the value, the output of this operation, the results, okay, should be assigned, and that is where the equals come in, should be assigned to this variable here. Okay, so that is what we have. So once we have this, we will now display the chromosome and the count that was generated. So we say echo, we bring our double quotes, we say $chrome, we bring a colon, this is $1 sign here, and then we indicate $count, that is the count we did from this line here. Okay, so this is how we do it. So once we have this done, we add done, indicating that we have finished, we are done with the operation, so the loops should be closed. Okay, so this is what we have here. So once we have this, we are ready to continue. So let's close it. We will save the changes and then run the scripts. So just make sure you have the operations, okay, the commands the same as what I have here. So now let's close it. I am using nano, so I'll say Ctrl X and then I'll just save the changes like this. So now let's proceed. So now we can run the scripts. Please note that Linux by default does not allow the execution of scripts. So we have to add execution rights. And so we say chmod +X. And then we specify the file. Okay, we give the name. And then we run it. When you do an ls, you will find that the color of the file has changed, okay, indicating that it's executable. In some Linux, you have this change of color, but it's fine. Once we have entered this command, we are ready to go. So now we can execute the script. So we say /, and we call the script, and then we run it. So you will see that the chromosomes are being displayed together with their respective counts. Okay, so this is how we do it. So notice how this has been done for us quickly. Okay, so let's clear the screen. If you compare this here we have 1, 2, 3, 4, 5, 6, 7, just 7 lines. Okay, and it has been able to do the activity for us, and then it's much better than you having to repeat the commands 24 times. Okay, this is much simple, efficient. Okay, and it's also very flexible. Okay, because of the loops here. So this is how we use scripts to automate some of the bioinformatics activities we do, especially if we are processing large amounts of files. Okay, so just take note of that. So this brings me to the end of this tutorial, and if there's anything that needs to be improved in this exercise, just put it in the comment section and let's discuss. You can also watch the videos in this playlist and then learn how to manipulate VCF files. Thanks for watching this video, and I will see you in the next session. Goodbye.